3.1, prove the following identity, and it's 4 marks. Remember, when you are proving, you need to simplify the left hand side, or you simplify the right hand side separately, and then you simplify until the left hand side is equal or identical to the right hand side. In this case, there is nothing to simplify on the right hand side, so let's start with the left hand side. Left hand side here is equal to, looking at our left hand side there, we have two fractions. Let's put them together using a common denominator there. It's sine x bracket cos x plus 1, and then this is our common denominator, LCM, and then multiply this by that to get sine x squared, and then there's a plus, multiply this, and that we have cos multiplied by cos x multiplied by cos x plus 1, close the bracket, and this is going to be equal to, clear this bracket, we have sine x squared plus cos x squared there, that is cos x times cos x, and then cos x times 1, that is distribution there, that is plus cos x, and this is all over sine x bracket cos x plus 1, and then from there we have this sine x squared plus cos x squared. That one should give us a 1. Remember the square identity, so this is 1 plus cos x all over, this is sine x multiplied by the bracket of cos x plus 1, and then we have two things here. This is, if we put it in bracket, there is a 1 is a coefficient, and then this is this, and that they are equal there. Cos x plus 1 plus cos x, they cancel each other, so we are left with 1 over sine x, and this is equal to our right hand side. So that's how you're supposed to prove this identity. And then the second question is saying, for which values of x is the identity in 3.1 undefined? All right, when we talk about something that is undefined, when you talk about these ratios, when you are dealing with these ratios, just remember the denominator cannot be equal to 0. So the values of x for which this thing is undefined, it is when this one here is equal to 0, that is cos x plus 1 is equal to 0, or the other denominator is sine x there, or when sine x is equal to 0, right? So when the denominator is equal to 0, if we were having tan x there, remember tan, the graph of tan has asymptotes, so if we were having tan x there, we are going to state the asymptotes as the values of x for which that thing is undefined. So we need to write this. These are equations. So this is cos x is equal to a -1. Cos x is equal to -1. Remember the graph of cos x is -1 when x is equal to 180 there, right? So the general solution for this one it will be x is equal to 180 plus 360k, where your k is an element of z. That is for that one. And then for this one, remember the graph of sine x is a boundary angle here. Sine x is equal to 0 when x is equal to 0 and when x is equal to 180 degrees. So we can write two general solutions here. X is equal to 0 plus 360k, or x is equal to 180 plus 360k, right? These two can be simplified or can be summarized as one to be x is equal to 180k, right? Where k is an element of z, that is plus or minus, right? When k is equal to 0, we will have 180 times 0, then we have that 0 there, and then when k is equal to 1, we have x is equal to 180 times 1, and then when k is equal to 2, we are going to have x is equal to 180 times 2, that is 360. So these are the two general solutions that we have. This one and this one. That is for this one. And then the third one, solve for x. All right. This looks like a trinomial, but we have two different ratios there. We need to substitute and get rid of one of the ratios so that we have uniformity there. This can be replaced with 1 minus sine x squared, and then we have minus 5 sine x plus 1, that is equal to 0. So we have 2 minus 2 sine x squared minus 5 sine x plus 1 is equal to 0. The 2 comes and joins this one to be a 3, so we're left with negative 2 sine x squared minus 5 sine x plus 3 is equal to 0. Now we have a trinomial. Let me write it in a simpler way. Our trinomial there. Okay, there we are. Our trinomial, we can write it as negative 2m squared minus 5m plus 3, that is equal to 0. I believe you are more familiar with this one. So in this case, I'm just saying my sine x is equal to m there, just to work with something that is clearer. Multiply through by a negative 1, there we have 2m squared plus 5m minus 3, and that is equal to 0. And then we can solve solving this equation. Solving this equation, what do we have? We are going to have 2m minus 1 bracket, and the second bracket will be m plus 3, and that is equal to 0. And remember, we said our sine x is equal to m, so we can bring back our sine x to have 2 sine x minus 1 there, and the second bracket is sine x plus 3 is equal to 0. And then our 0 factor law there, either this bracket is equal to 0 or that bracket is equal to 0. So we have 2 sine x minus 1 is equal to 0, or sine x plus 3 is equal to 0. Simplifying or isolating sine x, here we have sine x is equal to 1 over 2, or sine x is equal to negative 3. Remember, our sine x can only be between negative 1 and positive 1. I can use this to remind you. This is the function of sine x. This is 1 and this is negative 1. It cannot go down to negative 3. It's not there. It's only ending with negative 1 there. So this one should be NA. And then this one, your reference angle there, x is equal to the second function or shift of sine, and that is equal to 30 degrees, right? And then is positive, so we'll go to the first and second quadrant. From the first quadrant there, your x is equal to 30 plus 360k, and then from the second quadrant is x is equal to 180 minus 30 plus 360k, and that is equal to 150 plus 360k. All right, we are done with our general solution. This is the general solution there, and this is the second one. But we have not yet finished. Remember what we are told here. We are told that x is between negative 180 and positive 180. So we need to get specific values. When you are given something like this, you are supposed to give specific values for the values of x there. So our x should be between negative 180 and positive 180. Now, let's make use of the values of k. When k is equal to 0 there, we will get a 0 here. Let me use red. We will get a 0 here, so it's 360 times 0. So your x there is equal to 30 degrees. It is within our range here. When k is equal to 0 also for this one, your x will be equal to 150 plus 360 times 0. So that is 150 there. Now, when k is equal to 1, we'll have 30 plus 360 times 1. That gives you 390, which is well above our range there. Even this one, when k is equal to 1, it will be way above our range. How about when k is equal to negative 1? When k is equal to negative 1, we put our negative 1 here. That is negative 360 plus this, it will be negative 330. And then this one, if we put our k is equal to negative 1, this will be negative 360 plus 150. Plus 150, what will give? It will give us 200 and negative 210, and it is not within our range. I think those are the only two values that we have for k. So whenever you have something like this, always give the specific values. You don't stop with the general solution. All right, that's all for now.